Hello everybody, today we are going to be talking about covalent bonding. This video is going to focus more on the different formulas and ways that we can represent covalent compounds. First of all, what is a covalent compound and what is covalent bonding? Covalent bonding is the sharing of electrons. We also know that the polarity of bonds refers to how equally the electrons are shared. And two important vocab terms are that a bonding pair is the shared electrons, and a non-bonding pair are the electrons that do not participate in bonding. There are four different formulas that we can use to represent covalent bonds, and those are the molecular formula, the Lewis dot formula, the Lewis structure, and the structural formula. The first atom that we are going to work with today is dichloride. And the molecular formula for dichloride is Cl2. Now, to make the Lewis dot structure, we know that our bonding pair and non-bonding pair are both going to be represented by dots. So we have two Cl's, and we know that each of these has 7 valence electrons. That means this diagram is going to need a total of 14 valence electrons distributed in a way that each of the chlorine atoms has an octet. This means that there will be a bonding pair in the center, so we can subtract 2. That means we have 12 more valence electrons to work with. We divide that with 2 chlorine atoms, and we have 6 more valence electrons left, which can be distributed around chlorine as shown here. Now, our Lewis structure is very similar to the Lewis dot structure, with the exception of the bonding pair, which is the pair that shows how chlorine is sharing electrons right here. So this is represented by a dash, and then we can still have our 6 lone pairs around the outside of chlorine. And the structural formula, which is sometimes referred to as the skeleton formula, is shown with only a dash in the center. It only represents the bonding electrons. It does not represent any of the lone pairs. Next, we have water, which is represented by the molecular formula H2O. Now, hydrogen always forms one bond, and we know that oxygen has 6 valence electrons. So that means this Lewis dot structure is going to have a total of 8 valence electrons. So we are going to put our O right here and the H is over here. Like I said before, hydrogen forms one bond each. That means we're going to have a bonding pair in the center. And we have 4 more valence electrons left, which will be shown right here. And that is our Lewis dot structure. Now to form our Lewis structure, we are going to have an O and 2 H's. The bonding pairs can be represented by dashes. And then we are going to have our lone pairs represented. Our structural formula is going to look just like this. O, H, H. And we're just representing our bonding pairs. Next, we have ammonia. The molecular formula for ammonia, which is usually given to you, is NH3. Now, our Lewis dot is going to have N in the middle and 3 H's surrounding. Those are all going to be connected by a bonding pair. And we still need to cover 2 more valence electrons, and those will be represented as a lone pair for nitrogen because nitrogen needs an octet. Now our Lewis structure is going to look again very similar to our Lewis dot structure, except instead of those bonding electrons, we will be representing them by dashes. And the structural formula will look like this. Next, we have carbon tetrachloride. The molecular formula for carbon tetrachloride is CCl4. Carbon here, and then tetrachloride there. Now our Lewis dot structure, this is where it gets a little more messy because we're working with more electrons, but it will show a C in the center, and then we will have 4 Cl's surrounding. Now those will all be connected like this. We know that carbon has 4 valence electrons, and we know that chlorine has 7. 7 times 4 is 28. So this will have a total of 32 valence electrons, and we just used 8. So now we're only going to need 24. Only going to have 24 left, and we can divide that by the 4 chlorines, and that means each of them needs 6 more, which makes sense because this will give every single one of the chlorines an octet. Now the Lewis structure is going to show the same exact thing, except we're going to represent the bonding pairs as dashes. And again, we're going to surround the chlorine atoms by 6 additional valence electrons. That way each atom in this structure is going to have an octet. Now the structural formula of carbon tetrachloride is going to be a C in the middle with Cl surrounding it. The molecular formula for hydrogen peroxide is H2O2. And the Lewis dot structure of this is going to be 2 O's, 2 H's. The H's are going to be connected with 1 bond. And that means we still need an octet for the O's, and we will give them an octet. Now for the Lewis structure of this, we're going to show again 2 O's, 2 H's, and their bonds will be represented by dashes, and we will of course give them an octet. The structural formula, or the skeleton formula of this, is going to be as shown here. Next we have hydrogen sulfide. The molecular formula for hydrogen sulfide is going to be H2S, and the Lewis dot structure of this has an S in the middle and 2 H's. Of course, there will be a bond in between these, and we will give S its octet. The Lewis structure of this is as shown. And our structural formula is shown here. Next we have phosphine, and the molecular formula for phosphine is pH3, and the Lewis dot of this has P as the center with 3 H's surrounding it. Of course, there's a bond, and P needs an octet, so we will have a lone pair up there. The Lewis structure of phosphine looks like this, with a P in the center, surrounded by 3 H's. We'll have 3 dashes and a lone pair. And the structural formula looks the same as the Lewis structure, but without the lone pair. Next we have ethane, which is a special case, and that is why I put it in this video. Carbon always needs 4 bonds, but here is the exception. So the molecular formula is C2H6, and the Lewis dot of this will show 2 C's and 6 H's, and those will all be connected with bonds, of course. There we go. And our Lewis structure of this will be represented with just dashes. And in this instance, the Lewis structure is the same as the structural formula. That's because there were no lone pairs in this example.